Okay, so welcome back. So now let's discuss computer addresses. Computer addresses. You will agree with me that if I know your house address right now, I can easily locate you. I can easily send you a package. I can easily send you a message. The same way, if you know my house address right now, you can easily locate me, come to my house, or send me a message. Okay, so now computers too, they make use of address. They have their own address that they use in locating one another on a network. So now, what are these addresses? There are two categories of these addresses that computer uses to locate one another. We have MAC address and we have IP address. So now, what is MAC address? I want you to think of MAC address as a name of a person. Name of a person doesn't change, irrespective of the location. Whether they are in UK, if they relocate today, their name is still their name. Okay? Anywhere they are, their name is still their name. Anywhere I find myself, my name is still Ololade Adewumi. So, MAC address of a system does not change. It doesn't change. Okay? It comes with the system. It is a unique identifier that systems use to locate one another. So it comes with the system. It is like a stamp from the manufacturer of a system. Okay? It's just like when you were given birth to, a name was stamped on you that as from today, this is the name we'll be calling you. The same way, when a system was produced, when a laptop was produced, when a mobile phone was produced, when a printer was produced, there is a name stamped to it that this is the unique identifier that you'll be bearing. This is the name you'll be bearing. It is called MAC address. That is the MAC address. Okay, some people call it physical address. Some people call it hardware address. Anytime you see this, they are still referring to the MAC address. Okay, so now let's talk about IP address. Let's talk about IP address. Before that, can you see this picture here? This particular picture is a very simple network here, whereby this PC here is trying to send message to one of the PC here. So now, what they will leverage in this regard is the MAC address for them to be able to exchange information. So now, let's talk about IP address. Think of IP address as the location. Okay, I can change location today. That means my location is changing, but my name is not changing, which is my MAC address is not changing, but my location is changing. So see MAC address, see IP address also as the location of a system. Okay, the IP address is used to locate where a system is located, where a system is situated at a particular point. Okay, it is when you now get to that location that you now use the MAC address to identify it. Okay, it is when you have located the system using the IP address that you will now call the MAC address to pick it out so that it can receive whatever message that you have for it. Okay, so that is an IP address. And also, MAC address is made up of 48 bits. It is made up of 48 bits, usually written in hexadecimal format like this. Okay, you can pause this video and follow these steps on how to check your system MAC address and IP address. Okay, all what you need to do is to press Windows R, enter CMD, press enter, and just follow the instruction. You can easily check your system MAC address. So now the MAC address is made up of 48 bits. Okay, usually written in hexadecimal format like this. Okay, this is in 8 segments. 1, 2, 3, 4, 5, 6. Okay, 6 segments. 6 segments. So in each of the segments, you have 8 bits. You have 8 bits written in hexadecimal. This is 8 bits. This is another 8 bits. This is another 8 bits. This is another 8 bits. Okay. We call each of these octets sometimes. Whenever you see me mention octet, I'm referring to each of these segments in which these addresses are divided into. Okay, we call it octet sometimes. Okay, so that is MAC address format. So IP address normally look like this. It look like this, something like 192.168.10. Something like this, 128. So don't worry, I will elaborate more on this in the coming slide, in the coming training. So these are IP address look like, and also to find your phone's IP address and MAC address, I put the step-by-step to follow there too. So you can pause the video and check your phone IP address right now that you are using to connect to the internet you are using. Okay. So now let's talk about IP address further. IP address are in two fashions. We have version 4 and we have version 6. We have version 4 and we have version 6. Version 4 and version 6, they serve the same purpose, which is to allow communication between systems. Okay, but they are in different formats. Just the same way we have Windows 7, we have Windows 8, we have Windows 10, we have Windows 11. They are all serving the same purpose of operating system, but they come in different graphics, in different format and structure. Okay, so also IP address are in two fashions as well. Okay, so take note of that. So version 4 is 32-bit in size and it is usually divided into 4 octets. I will explain that later, don't worry. So, and it is usually represented in decimal for you to be able to quickly make use of it. Okay, so now while version 6 is 128-bit in size, is very large, is bigger than version 4. Okay, and it is divided into 8 octets and usually represented in hexadecimal. Don't worry, I have a class that I dedicated for IP version 6, where I will break down better on version 6 so that you can understand better how version 6 look like and how it operates. So as we continue this lecture, whenever you hear me mention IP address, I will be referring to IP version 4. So for the rest of this lecture, we'll be using version 4. We'll be focusing on it. So let's break IP version 4 IP address version. Let's break it. Let's break it down further. So like I said, it is a 32-bit size address. 32-bit size address. So let me explain how I come about all these that we have here. I said it is divided into 4 octets separated by period, that is dot. And meaning when you separate it, we have 8 bits in each octet or in each segment. Okay, that is why I have 8 here. I have 8 here. I have another 8 here. This is another 8, and this is another 8. Okay, you still have same 32 bits. Okay, so this is the format you will be seeing, but it will not be written like this. So let me quickly explain this on the drawing board. Okay, so I believe you have understood your conversion class very well, where I talk about binary, decimal, and hexadecimal. If you have not gone through that class, please go through it so that you can have better understanding of what I'm about to discuss here. So now, Let's say you have 1 bit. You have just 0. Please follow me, please. You have just 0. This 0 can only turn to 1 maximum. You agree, right? That is why when they say 2 raised to power 1 equals to 2, meaning we can only have 0, 1. Okay, this is 0, this is 1. So this is value 1, this is value 2 equals to 2. Okay, let's bring this further. If you have 0, 0, that means this 0, 0 can turn to 1, 1 at maximum, at binary level. Right? But in between 0, 0 and 1, 1, there are other values. So that means, because when we say 2 raised to power 2 here, our answer is 4, right? That means there are other values in between. Okay, so that means we have something like this 0, 0, 0, 1. So give us 0, 0, 0, 1, 1, 0, 1, 1. Okay, if we convert this to decimal, this will be 0, this will be 1, this will be 2, and this will be 3. Please follow me, please. I'm heading to somewhere. So now, here we have 4 values now, 4 unique numbers. Now, this is 1, this is 2, this is 3, this is 4. That is how we got this 4. Okay, that is how we got this 4. Okay, so if we take this further again, we have 3 bits. That means this 3 bit can turn to 1, 1, 1. But in between, there are other values. So that means we will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0. No. This one will be 100. This will be 101. This will be 110. This will be 111. Okay, in this place, this is 2 raised to power 3 will be what? Will be 8. So if you convert this to decimal, we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. Okay, 1 is missing. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. This one should be 0, 1, 1. I said this. 1 is missing. This one should be 0, 1, 0, 1, 1. So let me quickly fix this. So this will now be 1, 0, 0. This will be 1, 0, 1. This will be 1, 1, 0, and 1, 1, 1. So this will be 4. This will be 5. This will be 6. This will be 7 in decimal. So that means we have 1, 2, 3, 4, 5, 6, 7, 8 unique number. Okay. So now we now said IP version 4 has 32 bits. So that means we are saying IP version 4 is 2 raised to power 32. We have 2 raised to power 32. This will give us around 4.2 billion thereabouts. 4.2 billion. Okay. So now this 32 bits is now being separated into 4 places. Into 4 places. In each of the division, in each of the place, we have 8 bits. So that will be 8 bits, separated by a dot, dot 8 bit, dot 8 bit, dot 8 bit. Okay. So now, if we are to go in the direction of how we've been doing our conversion from binary to decimal and all of that, this 8 bit will give us, that will be 2 raised to power 8, right? In each of the octets, in each of the division. When I say octet, this is an octet, this is an octet, this is an octet, this is an octet, 4 octets. So that means 8 bits will give us 2 raised to power 8, making this is 256. That means if we are to do it in binary, that will be 0, 0, 0, 0, 0 in 8 places. This is the binary representation now. This will be 0 in decimal. We have 0, 0, 0, 0, 0, 1. This will be 1 in decimal. If we continue like this, we later have 1, 1, 1, 1, 1, 1, 1. This will give us 255. Okay? That means in each of the octets, we can have 0 to 255. Any number that falls in between this range, 0 to 255, is a unique address. Okay? That means in this place too, we can have 0 to 255. 0 to 255. 0 to 255. Okay, so let's do another representation now. New representation of the IP address. So we said a valid IP address will be any number between 0 to 255, 0 to 255, 0 to 255, 0 to 255, separated by a dot. So now let's just bring out an IP address from this. So let's say any number, let's say 10 dot, let's say 40 dot, let's say 55 dot, a number between these, let's say dot 200. This is a valid IP address. Okay, any number that fall in between these range separated by a dot will give you a valid IP address. Okay, so let's bring out another one. Let's say 172 dot, let's say 16 dot, let's say 20 dot, let's say 5. This is another valid IP address. So far, all these numbers fall in between this range. What I want you to do right now is to go to the comment section and bring out your own IP address. Just type your own IP address. Okay, just make sure that any of the number fall in between 0 to 255 in each of the octets. Okay, so drop your own valid unique IP address there. I will be waiting for you. Okay, so in the next class, we'll be discussing different classes of IP address that we have. We'll be discussing subnet mask and all of that. Okay, so thank you for staying to this time. See you in the next class.